Good. Welcome back. This is Jan Hichu, and I'm unpacking the use of IESve as a performance building performance modeling program. And we're busy talking and working through the building template manager. But we're very much close to done with all the last inputs. Up to now, we've analyzed or defined the system that runs the system as the building as a whole. So where does the energy come from, and is there an air conditioner and so forth. We've also defined the spatial conditions, which actually effectively talks about whether it's naturally ventilated spaces or air conditioned. We also spoke about the internal heat gains, how that relates, and remember that is often based on profiles that you've developed in the profile database. And as I noted there, you can actually expand on that, and it doesn't need to only be as simple as we've done it now. Remember that when you talk about the system and the space conditions, that you have to define it also in the building systems um, shortcut, effectively as a template that you develop. And then finally, remember that we actually developing templates for building occupancy or use, if you want to say that in that way, the zone name. And in this case, we did simply just defining an office room, so our office building, and therefore it's all the same, effectively office one. We're now at the point where we talk about the air exchanges, that which affected. So remember we spoke about heat gains, that's additional heat, and then air exchanges actually starts talking about how fresh air moves into buildings, but how we remove heat or gain heat, depends on what the climate conditions outside would be. As you can see at the moment, there's zero air exchanges being defined for this building. So you will click on Edit Air Exchanges, and there you go. Similar to the internal gains, the same approach is used in the end, where you would like to define infiltration, natural ventilation, and auxiliary ventilation. Now, infiltration is something that's ever present. Infiltration refers to how leaky a building is, and in the South African conditions, it's quite varying, and some of the studies that's been undertaken have documented in the US leakage from 0.5 liters per second per square meter to up to 70 liters per square meter, or less than 2 air exchanges per hour to about 50 air exchanges per hour. So from very little to very high. And in practice, in terms of sustainable design approaches, and a lot of it's actually done with the related to the passive house or arguments. They try to lower the infiltration rates so that you can control the air movement. There is still questions about how appropriate it is for temperate conditions, but either way, in terms of modeling it, I think you have to have some idea of what the infiltration rate is for your South African conditions. So you can range from a highly sealed, well-designed set of windows from about 0.25 liters per second per square meter to 7.13 or 7.3 liters per second per square meter for a leaky building, effectively. So it's quite a bit of a range that you could use. And again, I would argue use data that's available or based on studies that are available. So if you use infiltration, you'll go and you can define a new infiltration. Let's just call that office infiltration. And similarly, you say define it to this template. You can use air exchange rates, or you can use liters per second per square meter. If you use air exchange rates, we can just say, well, we would like to have infiltration should be 0.5 or 1. Either the figures I've got with me is liters per second per square meter, and I would say 0.25 liters per second per square meter. Remember, air exchange rates actually talks about how much of the building volume, the internal volume, gets changed per hour. Infiltration rates can be adjusted, but it doesn't actually make sense because that's often how leaky a building is. So it's often just simply on continuously. And then you can say, well, does it come from any other point, offset temperature or whatever? And I would just say keep external temperature because that's actually the nature of infiltration. Similarly, you might now say, okay, what am I designing a naturally ventilated building or auxiliary ventilated building? Which auxiliary ventilation actually talks about air conditioning. Okay, so if you're designing a naturally ventilated building, again, you can say office ventilation or natural ventilation maybe, and it's naturally ventilated, and you can say, well, this gets assigned to the template, which means you will assign naturally ventilated templates. We now haven't, we've got an air conditioning system designed or applied to this system, so we won't do that. And again, you can define the airflow rates. In South Africa, you can look at the SANS 10500 section O, which gives general airflow rates, and I think these are often defined as liters per second per person. There's also definitions for air exchange rates per hour, and you must use the highest one in that case if you were to ever define it. But you can just use a basic. So if it's naturally ventilated, one can argue that naturally ventilated is not the same as infiltration. It's someone is opening and closing a window when they're using natural ventilation. Now, that can actually ultimately you can actually define a profile where it's dependent on temperature rises and higher temperatures or lower temperatures and so forth. And if we start moving into using macro flow, which is another program here, then you can even get even more detailed in terms of that. But for now, you can just say if you use naturally ventilated buildings, you can use office occupancy. And again, it'll be outside external air. That's what it is. Auxiliary ventilation, which we'll define now. Again, you can call it office. What do we call this? Office in the end. We'll just add office at the start. And you just say, okay, this gets assigned to the template. We use actually the same argument as we would have used for, so we will comply to SANS 10400 section O. And again, we'll say, well, if it's auxiliary and it will be air conditioned, then we will use office occupancy for that. Again, the adjacent conditions, I would just simply keep to external air. I mean, if it is air conditioned, it will actually be regulated in the model, so don't worry. And you can say apply that to this template, and you save it, and you'll see currently we have only applied infiltration and auxiliary ventilation. You can now go and say, no, you know what, it's actually not correct. I've made a mistake. This mustn't be applied to the template, but natural ventilation must be applied to the template. You can click on it, and you'll see now it's naturally ventilated. Beware though, then you have to go back and adjust your office, your space system, which at the moment is still air conditioned, and then you have to say, no, wait a minute, it's got to be naturally ventilated as a system. So the only thing to remember here is do keep consistency in your model. You don't mix it up. If it's a naturally ventilated building, keep that natural ventilation all the way through. That will mean that your heating and cooling profile will be null and void now because it's naturally ventilated. But that doesn't need to be changed. But then you can say, okay, we're using a natural ventilated building. And that is the end of our inputs. Like I said, you can go and adjust the thermal comfort parameters. Do they wear less than one clo per as minimum? And I think in South African conditions, you might say, oh, I don't know whether everybody comes to office in a tie and a suit. Maybe that should be less. Similarly, you can say, and most of the time, we say people are comfortable with any speed below 0.125, and so forth. So you can go and adjust this, but I'll be very careful of doing that because you've got to base it on really well-founded research. And again, if you are using a thermal comfort index, then that will be based on these conditions, and then that means you can't use your index. Okay, so we've basically now defined what the inputs are. The one thing we haven't defined yet, and we'll do it in the next video, will be the construction of it. I won't go into all the construction aspects. We'll just do one material, but we'll do that in the next video. So thank you. See you in a bit.